Welcome to Activist MMT, a podcast about real-world economics, including modern money theory, and how life changes when you discover it. I'm your host, Jeff Epstein.
Activist MMT podcast special video episode series. I'm your guest host, Jonathan Wilson, and today I'll be interviewing Sam Levey. Sam is currently studying to get his PhD in economics at the University of Missouri at Kansas City. In this episode, we'll be discussing in detail Sam's 2022 paper, Optimization in a Neo-Chartalist Model of the Determination of the Price Level. The paper contains some rather advanced math, but I'll be asking Sam questions from the perspective of a non-math expert for the benefit of the audience. In the first section, we introduce the purpose of the paper and explain some basic assumptions in mainstream economic models and the advantages and disadvantages of using the mainstream approach. In the second section, we start looking at the text of Sam's paper. It contains 6 variants of the model, and we spend this section of the video looking at the basic one-period model. In the third section, we go on to the multiple period model. About 14 minutes into discussing the multiple period model, we shift from looking at the paper to viewing an interactive modeling software that allows Sam to show in real time how the model reacts to changing various inputs. In the final section, we conclude by discussing more of Sam's concerns with the underlying assumptions behind mainstream economic models, including 1. The definition of rational behavior and the trouble applying it to the real world, 2. Whether we need formal models to validate the existence of behavior that can be directly observed, such as precautionary saving, 3. Whether markets clear and what models with non-clearing markets look like, and 4. Whether the Lucas critique, which argued that models need optimization, actually improved economic scholarship. Let's get started. Anyway, so why don't we talk about your most recent paper, Optimization in a Neo-Chartalist Model of Determination of the Price Level. Now, I went through it the best I could, but without sort of advanced math, I could only get so far in terms of the understanding. For example, I started to get really tripped up the moment you started talking about something called a Lagrangian, which is on page 5 of 20. So I got a quarter of the way through before I was like, okay, not sure what's going on.
Do you want me to, would it benefit the people listening if I just explain what this paper is and, why I wrote it and what it's about real quick? Or
yeah, we probably need an introduction that is better than what I just said. So why don't you tell us why you wrote the paper and what it's about?
Sure. So this paper is actually a follow-up to another draft paper I've been working on that got released last year. It was like a Levey Institute working paper. And the theme here is formalizing MMT's theory of the price level. Mosler tells a story when he explains MMT to new people that often involves I'm sure all the MMTers have heard this. It's like his kids and his business cards, and he uses a tax that they have to pay in the business cards to get them to do chores. Or there's another version where he's talking about people in the streets of Pompeii, and the government issues the currency that people then need to get to pay the taxes or whatever. And part of the story involves, what is the currency worth? What are how many chores can Mosler get his kids to do in exchange for one business card? And they're intrinsically worthless. The kids do not give a crap about business cards. But once you have this tax issue, then You got to get the money to pay the tax, or else something bad's going to happen to you. And how much work you have to do to get one business card is just totally up to Mosler as the parent, as the government in this situation. He could say, like, you have to clean the dishes for 20 minutes to get one business card. Or he could say, you have to clean the dishes for 40 minutes to get one business card, right? Like, he just makes up a number, and then that becomes how much the business cards are worth. And so when Mosler tells the story, he'll talk about, like, the state is the monopoly issuer of its own currency. And monopolists set price. If you're the monopoly seller of something, you get to determine the price of that thing because you have no competition. So in the other paper, what I'm trying to do is, like, take this story and make some math out of it, give it a formal presentation to demonstrate that, it makes sense. And so I do that in the other paper. As far as I know, it's the first time anybody had done this. And it's pretty significant because, formalizing MMT, that's cool. Also, mainstream economics has a problem here. Like, if you ask mainstream economists, where does the price level come from? Why is money worth how much it's worth and not like 10 times more or 100 times less, right? They have some answers to this, but they're mostly bad. And they turn out not to make a ton of sense. And even the people who, are putting them in the textbooks will kind of admit, like, these aren't great answers to this question. But this is a totally, MMT's story, the story that Mosler tells about what value the business cards have. Why is it 20 minutes of dishwashing rather than 40 minutes? Well, because Mosler says so, because the government says so. That's what they're charging you to get a business card. This is the price that government pays when it spends, right? The business cards are money. The dishwashing is what the government's buying. They're buying some labor service here. And when they pay some price for that, that's defining the value of the currency in this very simple, stylized MMT story. And I don't think mainstream economics, to my knowledge, has ever really grappled with this theory. So it fills a hole in mainstream economics as well. So in this paper, what I'm doing is following up the other one. I'm doing the exact same thing. It's the same theory, the same story that you could tell, except it's using tools that mainstream economists are comfortable with. Like, if you do orthodox economics, because their approach believes that an individual and the choices that an individual makes are the thing that is important in the economy. And so every model that you do in mainstream economics basically starts with, here's an individual, here's the choices that they face, and they have some goal, and they're trying to maximize their happiness, usually maximize their utility, and they make the best possible choice, the optimal choice, so as to maximize their utility. And basically every mainstream model has that in it, and if you can't tell your story without that, then they won't listen to you. And so the purpose of this paper then is to retell the same story, but using individuals making choices and choosing the optimal outcome to maximize their utility, all that stuff, basically to get mainstream economists to listen and take this idea seriously. The paper itself is really a communication device. It's supposed to be an olive branch to people in the mainstream of the profession who otherwise would refuse to have this conversation. And I don't think that the paper itself tells us all that much. Like, certainly the other model, all the behavior is about the same, the outcome's about the same as what was in the other paper. And really, I'm not even sure we needed that paper because Mosler tells the story, and the paper, both papers are just the same story, but with math. So it's just really just a language thing. But anyway, this paper tells that story in a language that I'm hoping these people will listen to so we can get their feet in the door, so that we can have some mainstream economists go, oh, there is something worthwhile in MMT, and maybe I should learn more about what's going on there. Because I think a lot of mainstream economists have just decided that MMT is worthless. There's no scientific content there. I don't need to pay any attention to it. And that's because Paul Krugman wrote an op-ed, dissing MMT, and Paul Krugman's, he must know what's up. So I don't need to learn anything about this. Right? I think that's the reaction from the rank and file mainstream economists by and large, is that the gatekeepers have said you don't need to do this. This is not worth your time. And so what I'm trying to do is say, no. We can walk your walk if we really want to. There is something worthwhile here. I'll stick it in your language if that's what it takes to get you to listen. So that's what this paper is about.
You mentioned sort of at the end there that, this is about showing that you can walk the walk if you want to. Can you talk about why, initially you might not want to walk their walk and put things in their language?
Sure. So I'd say there's two main reasons. Number one, is the reason you said earlier. You got to page 5, and then it stopped making any sense, right? This kind of language is inaccessible to people who have not spent years studying economics, and that from a just general well-being of society perspective is bad. People should be able to understand our work. Right? Economics is about everyday people's lives. You encounter the economy every day. There's no reason why a description of what's happening in the economy should be completely incomprehensible to a reasonably smart person. Right? And but this language that the mainstream economists use and demand for every paper that they can to consider it worthwhile is very, very opaque. It's very hard to make sense of if you haven't learned the mathematics, and that sucks. That's not power to the people. That's building an elite that are only talking to each other. So that's one reason, right? Is it's not inclusive. Another reason is that most people in the heterodoxy don't share this view that individuals making the optimal choices is really the thing that matters in the economy. Not to say that it doesn't matter at all. Individuals make choices and, collectively we make up the economy, and that's all true. But in this view, it's just, to me, it's it's overhyped. They're saying this is the only thing that matters. This is the gatekeeping that if you don't do it, you're not doing economics. And from my point of view, no, lots of other things matter too. And in some cases they matter more. Right? And maybe in most cases even. This model is a great example. You don't even need individual optimizing behavior to make the point in this model. Right? The previous paper I had with the other mathematical model doesn't have that, and you get the same results, right? So it's not making a difference, right? What's driving the model is the way the institutions work, right? And so something about the structure of the system itself guides us to a particular outcome. The choices that people make within the system are severely constrained, right? And don't really determine the outcome. Maybe they determine who gets what within the system. If somebody makes better choices, then they get more of the pie or whatever. But if how big the pie is determined not by the choices but by the institutions, then you don't need these tools to answer those questions. And in fact, these tools are a distraction from getting the right answer. So that's just kind of an example, but long story short, people in the heterodoxy think that these tools have a lot of problems. I think some people in the MMT community would basically say you should never use these tools. You should never do individual optimizing. I don't think that. I think it's just overused. It shouldn't be a gatekeeping device. It shouldn't be if your paper doesn't have this, then it's not real economics. But I wouldn't say that they never have a place.
Right. And what would you say is the benefit, if there is any, to the optimizing methods in this paper that were not in the present paper, in the previous paper? What are we gaining here in terms of understanding?
Yeah. See, I don't really think we gain all that much. There were like a couple, it's not like I learned nothing from doing this paper. I learned some stuff about the model. But the big gotchas, the big takeaways are in the other paper. The process works the same way. And so it's just like, I don't know. I feel like we don't gain that much. Really, I did this as like I said, to get people in the door, right? As a communication or teaching exercise, to speak the language that those people want to listen to, because I think it's worth talking to those people. I know not everybody in the MMT community agrees with me about that. Some MMTers, I think, would say, like, if they aren't going to take us where we are, then they're not worth talking to. And I just personally don't agree with that. Maybe I'm just a little more optimistic, but I think there are worthwhile conversations to be had, and meeting people where they are is something that's, I think, useful to do, as long as it doesn't, as long as, like, I'm not saying, like that's how I'd answer your question, is like, we don't learn that much. We don't gain that much in this paper from these methods. And I'm pretty upfront about that. I'm not trying to, like, just pretend that, oh yeah, this is great. The mainstream approach, that's what we should have been doing all along. I don't think that. The point of this paper is just to have conversations. And I guess there's one more issue here, which is that somebody was going to do this anyway. There's sort of a famous nickname that Joan Robinson had for people like Hicks and Samuelson. So Keynes comes along and writes the general theory, and then you get people trying to interpret the general theory, like trying to be like, what did Keynes really mean? And you get these American quote unquote Keynesians who develop like this model called the ISLM model, and whatever, that kind of becomes, not to go too history of economics here, but it becomes something called the neoclassical synthesis, where they take the old ideas before Keynes and then slap a few Keynesian elements on it, and they say, we figured out Keynes. We got it. He just added a few new things to what we were already doing. Joan Robinson and these people who were closer to Keynes say, like, no, this wasn't Keynes. This is bastard Keynesianism. You've taken his work and you've bastardized it. You just integrated a couple things into what you were already doing, and you didn't really learn the point, right? You didn't go with the spirit of Keynes's work. And so my thought on that is, somebody is going to do that. The work is going to get bastardized. Who do you want to do it? Like, if somebody's going to do it, and I think it's inevitable that somebody does it, better us than them, right? Is like, yeah. If somebody was going to combine mainstream methods with MMT approaches, better that we do it, so that we can, like, steer this in a productive direction.
I see. You're trying to get in front of the conversation.
Exactly.
Yeah, that's an admirable goal. It's both admirable for trying to get in front of it, and also very conciliatory of you, for mentioning how you want to be able to have these productive conversations. I think, sometimes we get a little too caught up in debate, but it is important to realize that occasionally there is either middle ground to be found, or, agreements that we can come to about at least, what the differences are in some of our underlying imperial assumptions. So I think what you're doing is super important. Speaking of sort of mainstream sort of bastardization of MMT, did you have any thoughts on, I think his name was Brian Albrecht, his model of the job guarantee?
Yeah, I know what you're talking about. I read that paper when they were doing the draft of it, and then I kind of skimmed it again, I think when the published version came out, if I'm not mistaken. There's some problems in that. First of all, I think that paper is actually a really nice example of trying to have a conversation. Like, I think they were doing honest, good faith work. They read some MMT stuff. They didn't just, quote Krugman. A lot of people do this, like you quote non-MMTers to tell your readers what MMT says, right? Those guys didn't do that. They did try to read MMT stuff and do some serious, so I think that was good faith work. And I really appreciate that. And I told Brian that too. There's some problems with their paper that, at some point I've been meaning to get around to writing a reply to it. Because the way they model the job guarantee uses like their own assumptions about what's going on in the economy and how the economy works and how the program would work to reach the conclusion that they reached, that the job guarantee wouldn't be effective.
I think they also make some political assumptions on what the legislature would do, if I'm remembering correctly. It was a while since I've read it.
Yeah, I had some issues with that as well. So it is on my list to write a reply to them. But yeah, that's how the process should be working, right? Is you read somebody's work, you try to make your best of it, and you reply and you develop your idea and you say like, well, here's my problem with this, this and that, and then a productive back and forth like that. That's what scholars, ought to be doing. And I think that MMT really tied itself up in social media, and that has done a lot of good for us. Like, it's really helped us build a popular following, which has helped us build political pressure and has actually shifted the conversation. Like the policy discussions around fiscal policy are way closer to MMT and what we're saying than they were 10 years ago. And that is in no small part thanks to movement building and organizing and stuff that people have been doing. But I think the underbelly of that is that on Twitter and in social media and blogs and stuff, tempers run high. It's really easy to start like showboating instead of having like level-headed debate. And while there definitely is a place for riling people up and getting people passionate about, the change we want to see, there's also a place for level-headed debate, and Twitter makes it hard to do that. And so I am willing to applaud any good faith engagement that I see. I have tons of policy disagreements with Brian Albrecht, and I actually get his newsletter. It's called like Price Forces, I think, or something like that. And every time I read it, I'm like cringing, right? But I believe those guys are sincere, and I appreciate the engagement. So yeah, my plan is to get back to them at some point.
Well, that sincerity, I think, is the first thing that you can hope for when you're having a conversation. But that's some great perspective on sort of what good faith engagement looks like. All right, why don't we start taking a look at this? So I read it the best I could. Some of the math I didn't understand, but I tried to follow along with sort of the arguments and the conclusions as best I could. And I sort of came up with my own sort of summary of what I think you're saying, which is that if there is a net tax burden on the private sector, meaning there's less money in the private sector at the start of the period than is needed to pay the total tax to the government, then by definition, at least one private sector agent must sell to the government to get the money to pay its tax at the government's price. And we know that this sale must take place at the government's price because the seller who needs to pay his taxes has no reason to accept less than the government's price from another private sector seller. And two, if there's a net tax burden, the other private sector buyers would eventually run out of money and would be unable to pay more than the government's price. So that's sort of my interpretation. And hopefully that will be helpful to the viewers, even if it's wrong, as sort of like a way of sort of like a starting point in terms of like how to correct any misconceptions. But I'd like to hear sort of your thoughts on what I just said, if that's close or far away from your conclusions.
Yeah, I think it's pretty close. Some of the price dynamics might be a touch different, but like everything up till that bit was along the right lines. In broad strokes, the government has pricing power because you don't have enough money to pay your taxes yet. You got to go work for the government. You got to go sell stuff to the government. They get to dictate the price. And then through market forces, that ends up being the price in the private sector as well. I'll tell you what, so right now you're sharing your screen and we're looking at the paper. Do you want me to share the screen so I can like move the mouse around and point at stuff and whatever?
Yeah, that could be beneficial, actually. All right, so I'm going to stop sharing, and I'm going to give you a chance to share now.
All right. So I guess let's hit it, huh? So what the paper goes through, it actually goes through 6 versions of this model that are like in 2 categories. In one category, the government is running what is basically a job guarantee. And so that means like if you come to the government and you want to sell them stuff, they will buy all of it that you want to sell at some fixed price that they announce. And so that price is here. Can you see that highlight?
Yep.
So the price is called PG, the government's price. And in the second category, like the second category of models, instead of buying everything you want to sell, they set some limit, right? It's like, we would like to sell you 10 hours of labor, and the government says, well, we're only going to buy 8. So that kind of splits the paper in half. And then within each of those categories, we hit it 3 times. The first time is 1 period. So like, what if the game only happens once? The second one is kind of a general case, multiple period, like what if the game is a repeated game that, keeps on going. And then in the third one, it's like this. The third one is an example of the second one that's like a little bit more specific. So in both cases, both times, it's 2 periods, and we start specifying like, here's the utility function for the private agents, and I start drawing some graphs and things like that you can do if there's only 2 periods. So that's kind of the layout of the paper. So let's see. I guess let's do it, huh? We can kind of walk through here, and I don't know. Do you want me to just start talking and you stop me if you have a question, or how do you want to do this?
Oh yeah, then go start talking. I'll stop you if either I'm confused or if I feel like the listeners might want some detail on something.
Okay, great. So we start with the 1 period model, and this is this is like the highly unrealistic scenario that we have to craft for this model to work, right? And this kind of thing is standard in mainstream economics, and especially, actually, you'd be surprised, for monetary economics, where people are trying to figure out, how money works and how does inflation work and the price will come from. You see these like really, really simple models all the time that are highly unrealistic. And so that's what I'm doing here, right? So in this world, there is one consumption good which cannot be stored. So think of it as like, I don't know, maybe a gallon of milk. Okay, you're going to drink it or it's going to go bad. And that's the only good that exists that we're considering. Now we've got the government, and they issue money, and by money here we mean transferable tax credits, right? It's something you can use to pay your taxes, a tax credit, and it's transferable. You can sell it to somebody else. Okay, and just this is what I call, call that fiat money, call it currency, whatever you like, right? But that's what it is. And then we've got a representative agent. So in these models, it turns out to be really hard to model multiple people. And so the way that economists get around that is you model just one person that's called the representative agent. And depending on how you think about that, either this only applies when all of the people are identical. So if every person in the economy is completely identical, then we pick one of them and we call them a representative agent, and we can do that. There's some cases also where like the people don't need to be identical, and the representative agent is just like kind of the average person, and then it sort of can still work. But so that's what's going on here. We're going to model just one person, and we're going to call them representative.
And why is it hard to model with more than one agent? Is it that the math gets too hard, or is it conceptually hard to do, regardless of the math?
Well, it's both, I guess. It's that when you have different kinds of agents, then they start interacting with each other in more complex ways. And then putting that into math becomes very, very difficult. And so this is sort of the standard. I mean, there is a whole field that is working on this. It's called a heterogeneous agent. And so you'll hear about like heterogeneous agent new Keynesian models, or HANK. And to be honest, that's not my area of expertise. Like, I don't know a whole lot about exactly how those work. But there's kind of like a whole series of debates going like at least 100 years about aggregation. Like, when is it okay to treat the whole economy as if it's one single person to make the math easier? And when is it not okay to do that? And, it turns out it's mostly not okay to do that, but sometimes it's kind of okay. And economists probably do this macroeconomists probably do this way more than they should. But it keeps the math simple.
All right. Cool. Yeah. Let's go on. So we have a representative agent.
Okay. And so each period they get this real endowment of Y units of the consumption good. So Y is our variable here. The consumption good is like your gallon of milk. And this is, we're saying, you get like Y gallons of milk. They just drop out of the sky at the beginning of every period. And what we're doing here is we are abstracting away from how production works. Like, we're not going to ask where the milk came from. You could do this. There are mainstream models with production that model the decision to, produce the milk or whatever. But that is not necessary for the story we're trying to tell here. And so we don't worry about it. And so we're just going to say the milk comes out of nowhere, basically. You just, you start each period with 10 gallons of milk, or, whatever the number Y is. And then you're also going to start the period with some amount of money that you carried over from before now. So V0 or V0 is how you can read that. This is the money you start the game with. And then what can you do with this stuff? Well, you can consume some of the milk. So how much milk you consume, we'll label that C. You can sell some of the milk to other people in the private sector. And I'm going to call that SF here. S for sell. And I don't know why I picked F, but I picked it. So we're running with it. So the superscript F here means stuff happening in the private sector. So you sell some of the milk to the private market.
Next to G.
Yeah, I think that might be the reason. I've been using this notation for a long time, and I don't really remember why I picked it, but yeah, that's probably it. So you can sell some of the milk in the private market, and what the private market price is going to be, we're going to call it PF. That's whatever price is out there in the private milk market, let's say. Or you can sell it to the government and they pay PG for a gallon of milk. That's how much money they pay. You can also use the money you've got. You can buy milk from the private market, BF. And you have to pay taxes in money. And with this lump sum nominal tax here, what that means is like the tax is of the form, like you owe us $100. So it's not like an income tax. It's not like, a property tax. It's just straight, here's a number, and that's what you got to pay.
It's just a straight head tax.
Exactly, yeah. And that keeps the math simple for this model. So after you do all that stuff, however much money you have left over, we're going to call that V. Okay. And let's see. I think I already mentioned this. The government is going to buy all the milk that you want to sell to them. So they set a price. Maybe it's like $4 per gallon. I don't know. And however much milk you want to sell to them at $4 per gallon, they buy all of it. So that's how government spending works. And then, so because of like that the money has to come from somewhere and go somewhere. And because, you can't consume milk that doesn't exist, we end up with these two mathematical statements about how the things you use the money and the milk for are related. So this first one here Y is how much milk, just drops out of the sky for you. This is your endowment. That means like milk you just get every period, and we're not worrying about where it came from. And then you can also buy milk. And so on the left-hand side here, we've got the milk that you have obtained, right? Either it dropped out of the sky or you bought it. And that has to be greater than or equal to the milk that you sell. You either sell it to the government or sell it to the private sector, plus the milk that you consume. Right? Basically, we're saying you can't sell or consume milk that you didn't get from anywhere. You have to have gotten it from somewhere, right?
Okay, so this is there's no futures market in this model, essentially.
Well, in this model only has one period, so that is correct. There is no futures market, but there's also there's just basically just saying that the milk had to come from somewhere.
Right. You get it, and then you drink it or sell it.
Yeah.
Yeah.
And you could waste it. That's what the greater than or equals to here is. This is on the left-hand side is the milk that you get, and then on the right-hand side is what you do with the milk. And if the right-hand side was less than the left-hand side, that just means you're like wasting some of it. You're like not selling it and you're not drinking it.
Yeah,
and so that's allowed. But what you can't do is like consume milk that wasn't given to you somehow.
Okay, I'm following that.
Okay. And then we kind of have a similar thing with money. So over here, so V here is the money that you end the period with, that you end the game with. And how much money do you end the game with? Well, you start off with some amount, V naught, and then you get money by selling milk to the government. That's one way. And so that would be how much milk you sell to the government, SG, times the price that you sell to the government at. You can also get money by selling milk in the private sector. So how much you sell to the private sector times the price. You give up money when you buy milk from the private sector, right? Because you're paying the money. And then you also lose money when you pay taxes. And so we add all that together. That tells us how much milk you end the game with. Yeah?
All right, yeah, following so far.
Okay. So then, this is how it works in every mainstream model. The agent in this model has a utility function, which here we're calling U of C. And that tells you basically how happy you are. And your goal is to maximize your happiness, right? The utility function is like a number. It takes as its input how much milk you drink. So C is the input to the utility function. And it outputs some number called utility, where if it's a higher number, that means you're happier. It's like representing how happy you are from drinking milk. I don't know why I keep saying milk, because in the paper I did not use the word milk, but I don't know, it's working for me, so I guess I'm going to keep doing it.
It's a good example. Yeah, this is where I started to have questions at the very last sort of clause here, where utility is greater than higher, and then you have this DUC over DC is greater than 0, and I wrote down what is DU and DC here.
Okay, so you took calculus, right?
Yeah, back in, what was this, 2009? No, was it? Yeah, I think it was 2009.
Okay, so this is a derivative. So this is an object in calculus called a derivative. And what it tells you is like how the utility changes if the consumption changes. So the letter D here, let's not get into the history of this, but that letter D is supposed to signify a change. And so on the top is like a change in your utility divided by a change in your consumption. And so this ratio here is like, if your consumption increased by 1 unit, let's say, how much would your utility increase? And so like, if this is a positive number, that means that when your utility increases, If it's a positive number, then when your consumption increases, your utility also increases. So when you drink more milk, it makes you happier if this ratio here is a positive number.
Oh, I see. D doesn't have it, it's almost if D is standing for delta. I don't want to.
Oh yeah, that's exactly it. Yeah.
Okay, all right. So you're saying the change in the output divided by the change in the input is greater than zero. That's saying that the slope of this line is positive.
Exactly correct. Yeah, derivatives measure slope, and it is like the D is like a delta, except that it's like the limit as the delta goes to zero. Calculus stuff I'm not going to get into, but you're exactly right. It's a slope. And if the slope's positive, then your utility increases when you consume more milk. So you get happier, and so you want to do this. You're trying to maximize your utility, right? And so this would say, well, to maximize your utility, you should maximize how much milk you can consume. On the other hand, if the ratio were negative, then that would indicate that when you consume more milk, it actually makes you less happy. And so if you were trying to maximize your happiness, you should consume the minimum amount of milk.
All right, sounds all right. I think that makes sense.
Okay. So then in this next section here, we sort of get into a problem that I uncovered while I was trying to build this thing, which is that if you basically what we just did was lay out the model. Let me just glance ahead here. Yeah, that's the essence of the model, is like I just kind of described the setup. And it turns out that that is not enough information to solve the model, because you run into this problem where the model's going to tell us like how much milk you want to obtain on net. Like if you start off, let's say you start off with like 6 units of milk, and the model tells you, hey, you actually want 9, so you got to go out and get 3. Okay, so that's what the models can tell us that, but there's, in the way we've specified it so far, you could actually get 3 in a lot of different ways, right? And this is what I have right here, right? Is like, if you wanted to increase your holding of milk by 3 units, you could do that in a lot of ways. You could buy 3 units of milk, and you could sell 0 of them. Or you could buy 4 units of milk and sell 1 of them. Or you could buy 5 units of milk and sell 2 of them. Like each of those, all of those increase the amount of milk you have by 3.
Mm-hmm.
And there's nothing in the model so far that tells us which one of those you want to do. They're all like equally good. And so the model would have multiple solutions if we just did what we've done so far, right? Each of buy 3, sell 0, buy 4, sell 1. Those are just as good. And so the model has multiple solutions. And so we have to deal with that, we have to alter the model a little bit. It's basically got too many variables, right? And we have to eliminate one of them. And so the way I'm going to do that is define this thing called N, which I'm going to call the net demand. And the net demand, so we've got the amount of milk you buy minus the amount of milk you sell, both to the government and to the private sector. And so this is like this 3 right here, right? If you want 3 units of milk, right, you could buy 3 and sell 0, or you can buy 4 and sell 1, right? So this is gonna, if we redo this model in terms of N, this is gonna get rid of this problem. Okay.
Right. And what about this footnote here? I wasn't. I had a question about this. So you're asking about the net demand plus the sales to the government when the market is clearing. I think is the problem.
Yeah. Okay. I'm gonna say like table that one. Let me come back to that because that will make more sense a little later.
All right.
Yeah. Sorry about that. Okay, so we're redoing the model in terms of N, and so then these two equations, this one here, this constraint, this was about like you can only drink milk that came from somewhere. And then we had this one here that was like about where your money comes from and goes to. What we're going to do is we're going to rewrite those two in terms of n. So we got to do a couple little algebra games here to get these two constraints to have an n in them and to get rid of some of this extra, the b's and the s's. Okay, and so the first one of those is actually pretty easy, and we end up with this: y plus n is greater than or equal to c. So to see where that came from, if we go back to the original version here, right, you could take these two s's and subtract them from both sides of this thing so that now they get removed from the right side and now they're on the left side. And so then on the left side, you'd have y plus bf minus sg minus sf. And so that's just n, right? You would have n on the left side of that thing there. And so you can
able to do that simplification. The later
okay.
one got a little bit harder.
Yeah, this next one, did you get this one?
No, I got stuck at some point because you have pulling out you pull out PF and SG from the expression, right? But the second half of the expression where it says plus SG times PG minus PF, I'm not sure where that was pulled from because I don't remember where I couldn't identify where in the original expression you had SG being multiplied by PF.
Sure. Okay, I'll go through it, or I'll try at least. So what we're just to put it in context first, what we're doing is we're going to take this equation right here that tells us like where your money came from and where it's going to, and we're going to rewrite it so that it's in terms of n. So it's going to have n in it. And what we're going to start by to do that, we're going to take this bit of this equation right here, which again is like this is how much milk you sell to the government. You know this is how much money you get for selling milk to the government. This is how much money you get for selling milk to the private sector, and this is how much money you have to pay to buy milk from the private sector. So that's in this equation here. And we're just gonna look at that for a second. So I'm gonna copy that to right there. So there it is. And then, math people love this stuff. We're going to change it in a way that doesn't actually change it. Okay, if you add 0 to anything, you still get the same thing. And so we're going to add 0 to this thing, but we're going to add 0 in a clever way. We're going to add 0 in the form of this. PF times SF minus PF times SF. That's just 0, right? Because this is something minus itself. But we're going to add that to this expression up here, and then we're going to collect the terms. So, okay, if you consider this and also this at the same time, okay,
right.
Let's start by looking for, let's see, this would be a lot easier if I had a blackboard, but actually, if I do this on a little whiteboard here, would that be helpful?
I think so. I mean, I'm trying to think about like how, if we're gonna like mash this together. Probably the best thing to do would be yes, you can do that, but first stop sharing your screen and then turn your camera on. So we're recording the video through Zoom.
Okay.
Yeah.
All right, so can you see that okay?
Yes, sorry. PG, PS plus PF, SF minus PF, BF, and then you added on the 0, which is plus PFSF minus PFSF.
Yeah. So what we're trying to do here is get something that's going to look like n that we can swap out for n. And so what we can do is if we take like this term here, that's PFSF, and wait, hold on. I copy this right. Oh, yeah. Okay. Sorry. Oh, the joys of doing live algebra. All right. So I think it's actually going to be a little easier for me to walk this one backwards. So my apologies about that. Okay. So where we're going to end up looks like this. PF times SG plus SF minus BF plus SG times PG minus PF. Okay, so put it back so I can see it. So this is where we're going to. This is what we're trying to get. And the reason we're trying to get here is because if you notice this thing in parentheses, if you recall, this is the negative of what we called n. So we're going to write this as minus n times PF, just reverse the order, but that doesn't matter. This thing is minus n in the parentheses there.
Yeah.
And then we just have this second term here. And this is great because this has an n in it, and that's what we want. So this is where we're trying to get. And what I'm going to try to show you is that this is the thing that we start with, and this is where we're trying to get, and that these two things are the same thing. Okay? And I'm going to do that. I'm going to distribute, basically just multiply all this stuff and get all of the terms, and then we'll do a little subtraction. Right? So I'm going to multiply this thing, this PF, times each of the things in the brackets there. So we get PF times SG plus PF times SF, so PF times SF, minus PF times BF. Okay, so that's this term. And then this term here, we also need to distribute this. So we'll have a plus and SG times PG. And maybe I'll just write those in the other order just to be consistent with what's going on over here. So PG, SG, and then multiply this times this. I'll write it in the other order as well. PF times SG. Okay?
All right.
And then what we're going to do here is we're actually going to cancel out. We've got PFSG here, and we've also got PFSG here, but minus. So we've got a plus PFSG and a minus PFSG. So those will cancel each other out.
Okay, all right.
Let's see, is that where I want to go? I think that's where I want to go. PFSF minus PFBF plus PGSG. PFSF, that's here. Minus PFBF, that's there. Plus PGSG, that's there. Actually, if we go backwards, I guess we don't even need this bit.
Oh, all right.
Okay,
yeah.
The joys of live algebra. Sometimes there's some surprises.
Yeah, that's cool. I see that they're equivalent. I don't know. I couldn't figure out how to do it forward, but I see how you did it backwards.
Yeah, off the top of my head, I don't remember, but at one point, I figured out how to do it forward. So.
Okay. Well, I'll take your word for it that it can be done. It must involve multiplying something by SG, because that was the part that I couldn't replicate. But anyway.
All right.
That makes sense. All right. Now, do you think we need to use the whiteboard for the rest of the one period model?
I don't know until we get there.
Okay. All right. Well, all right. Do you want to go back to sharing your screen?
Sure thing.
All right.
You know what? I think this might just be a typo in the model. I think this 0 it says PFSF, but it might supposed to be PG, or yeah, PFSG. That might just be a mistake. But you can see their equivalent, so it does work out.
Okay.
Okay, so I'm going to share my screen. Okay. So, all right, just to remind you why we did all that, what we were trying to do is we've got this equation here that tells you where your money came from and went to, and we are trying to write that in terms of n, because we need to have this n here, because we had this problem with, if we just use BF and SF, then we have this problem here, right? Where you could buy 4 and sell 1, or buy 5 and sell 2, and it's the same. If we use n is just the 3, the 5 minus 2, then we get rid of that problem. And so we need to have n, and so we need to rewrite stuff in terms of n. And so this expression came from that equation that had v in it, and we have transformed this expression into this, which now has n in it. And so that's going to allow us to rewrite that equation that had the v in it like this.
Okay. All right, cool.
And let's leave it there with that.
And this is saying that the money you have at the end of the period is equal to the money that you start with minus however much the price that you end up paying is times the net demand of the things that you buy. So the number of units that you buy times the price, and then plus the number of things that you sell at the price paid by the government minus the price paid by the private sector.
Yeah, so loosely you can think of this as like the profit that you make if you were to buy milk from the private market at PF and then sell it to the government at PG.
Okay. All right. So I see. So your net, your money you have in the period is the money you started with, minus sort of your own sort of net demand, the cost that you pay to buy the extra things you want, plus this arbitrage opportunity minus taxes.
Yeah.
Okay.
Yeah. Okay, now we come to the fun part. Okay, so it's pronounced Lagrangian, and it's named after like Lagrange, the famous mathematician.
Okay.
And here's what this is. So this is a mainstay of mainstream economics. It's in like every paper is going to have one of these basically that does a theoretical model. And what they're for is for constrained optimization. So I said we're trying to maximize utility. We're trying to maximize how happy we are. We're going to choose like how much milk do we consume, how much money do we have, how much milk do we buy, how much do we sell to the government. We choose all those things with an eye towards trying to maximize how happy we are. And maximize, economists will also say optimize. So that's optimize in optimization, just means make it as good as it can be. And then constrained means that there's some limits placed upon us, right? If you kind of remember back to this thing here, this expression is telling us that more milk always makes us happier. And so if more milk always makes us happier, then to maximize our happiness, we should consume an infinite amount of milk. Okay, but the problem is that there's like limits on us. There's a reason we can't do that. And that reason is, the milk doesn't exist, or we don't have enough money to buy an infinite amount of milk, right? And so those place constraints on us. And so we're not just going to maximize or optimize. We have to do it in a constrained way. So constrained optimization. And if you're doing just regular, normal, or unconstrained optimization, so you're trying to maximize something and there's no limit on you, then the tool for doing that comes from calculus. And you take a derivative and you set it equal to 0. So what that means is like you're trying to find, if you've got like, maybe you've got how happy you are as a function of how much milk you drink, and to maximize it, you find the point where the slope is 0. So do you want me to do this calculus explanation, or like?
Yeah, sure. All right, let me just
Okay, in that case I will need the whiteboard again.
All right.
So just kind of like general calculus principle here. You've got some function, here's our graph, and here's some function, maybe it looks like this. And we could say we're in economics still, and this represents our happiness. It could also be just anything else, right? Just some, maybe this is like, this is, I don't know, how much gasoline goes through your engine per minute. And maybe this is like its fuel efficiency. I don't know. But what we're trying to do is find the point where this thing is maximized. And you can kind of see just by looking that it's like right here, right? That is the highest point. We're trying to maximize, find the highest point. It's going to be right there. Mm-hmm. That's the highest point of this function. And at this point, you'll notice that it has if we were to draw a line that was tangent to this curve, so that just touched it in one place, that line would be flat. Right? On the other, if we picked this point right here, maybe just some random point, and we drew a line that kissed the curve that just goes by that one point like this. Okay, this line slopes downward. It's got a downward slope. Whereas if, maybe if we were over here and we draw, it's called the tangent line, the line that just touches this curve in this one spot, right? Over here, it points upward. It's got this upward slope. But at this maximum, it's flat. It's neither pointing up nor pointing down. It's just flat.
Okay, so you're finding where the point at which the slope is 0, because that's where the utility or whatever your y-axis is the highest.
Yeah, exactly. To maximize anything, you find the slope, and you find the point where the slope is 0. Now, that doesn't necessarily have to be a maximum. That might also be a minimum, right? Because I'm going to draw another function over here, and maybe your function looks like this. Okay. So we could find the point where the slope is 0. It's going to be right here, right? If we draw the line, there's the slope and it's flat again. But on this curve, that's a minimum, not a maximum, right? But in general, yes, what you do is you find the point where the slope is 0, and that's going to be either your minimum or your maximum. And in calculus, the thing that tells you the slope is the derivative. So you take your function, whatever it is that you're trying to maximize, you take its derivative, which basically means you generate a new function from it that this new function tells you the slope of the old one, and you find the point where that slope is 0, where its derivative is 0.
All right, yeah, sounds good to me.
Okay, so I guess I'll share the screen again. Okay, so so you're trying to maximize something. You find its slope, you take its derivative. Those are the same thing. Find the slope, take the derivative, and then you find the place where the slope or the derivative are 0, and that could be a maximum.
Yeah.
So that works for unconstrained optimization. When there's no constraints, you're just trying to find the maximum. But sometimes you have these constraints, and so you have to use a slightly different tool that's called a Lagrangian. And it works very similarly, but it allows you to have the constraints as well. So the thing we're trying to maximize is this bit here. This is the utility function. It takes in how much milk we drink, and it tells us how happy that makes us. And we want to maximize our happiness, so maximize the utility function. But we can't just have an infinite amount of milk because we've got constraints. And so instead of just maximizing the utility function, if we just wanted to maximize the utility function, we would take its derivative, find the point where the derivative is 0, and that would tell us, how much our maximum amount is, and that would tell us to drink an infinite amount of milk, because more milk always makes us happier. So we need to do that, but we also need to throw some constraints on it. And this might be a little more complex than is worth us getting into too much, but the way you add in these constraints is you start with the thing you're trying to maximize, and then you create a new expression by adding terms that look like this. In the parentheses here is our constraint, although rearranged slightly. So you see we've got y plus n minus c. That comes from this. And we subtracted c to get all the terms on one side, and then we just took everything there and we wrote it in the parentheses right here. We did the same thing with the other constraint. So this first one is the constraint about, the milk has to come from somewhere. This second constraint is about how the money has to come from somewhere and go somewhere. And we're going to do the same thing here. We're going to subtract everything so that it's all on one side of the equation. And then we just copy that and stick it in the parentheses here. And so that's what this is. I think actually the only thing we subtracted is v. This thing on the left moves to the right, and then we've got the whole equation, and then we just stick that bit in here. And so what we're doing is we're constructing this new function that's called the Lagrangian that is equal to the thing we're trying to maximize, the utility function, plus these extra terms where each term has a version of the constraint times this new variable, and these new variables get called Lagrangian multipliers. And it turns out, and this is like too much calculus for me to try and really prove right now, so you'll sort of just have to take my word for this, although I think Khan Academy has a really good explanation of how this works. But it turns out that, remember before we said that if you want to maximize something, you take its derivative, find the slope, and then you find the point where the slope is equal to 0. It turns out if you want to maximize something with constraints, then you do the exact same thing, but to this object, to the Lagrangian. You construct this object called the Lagrangian, and then you find the slope, you take the derivatives, and then you find the points where the slope is equal to 0. and that gives you your maximum with constraints.
Okay, and these two Lagrangian multipliers, I forget what it's called. Is that like a lambda or like
Yeah, so this one's lambda here,
right,
and this one is the Greek letter mu.
Mu. And do those, are those constants, or is that just a variable that you've chosen for representation here?
So they have a meaning, and like you'd have to solve the whole system to figure out what, they are going to be some number. You'd have to solve the whole system to figure out what the number is. And they do have a meaning, which is sort of like, it gets called a shadow price. And it's like, how much, loosely what it ends up being is like, if you relaxed this constraint, how much more happiness would you gain? So like right now, maybe this Y here, remember Y is like how much milk you just get from nowhere at the beginning of every period. So maybe you just get like 10 gallons of milk it just appears. Okay, but what if you got 11 instead of 10? How much happier would that make you? That information turns out to be captured by this lambda right there. For this model, it doesn't have very much meaning. So you don't have to worry about that too much. But that is sort of how it works.
All right. And are you using a program to determine those, or when you were writing the paper, did you go through a whole proof to find out what lambda was equal to?
Yeah, so it's actually right here. There's just a couple lines of math to get there. Although putting all of this together, took me months. But yes, it's mostly mathematical proof. It's just like me filling pages of notebook paper trying to get it right.
Okay, all right, and so these are your conditions. This is how you, or this is what you sort of came up with after doing all of that. And can you tell us a little bit about what each of these are saying? So I'm recognizing your utility. You have your consumption here. You have that multiplier.
Sure. So
like a U prime, which is, well, I'll let you talk about it.
Okay. So just to recap, to find the maximum utility subject to these constraints that we have to deal with, what we're going to do is we construct this object called the Lagrangian, and then we take the derivatives of the Lagrangian, that's the slopes, and we figure out where those slopes are zero, and that could be our maximum. And so each of these things, you've got this, sometimes this letter here gets called del. It also gets called like partial. This is the partial derivative of the Lagrangian, which means like it's a slope but in multiple dimensions. This is like in like 4 dimensions or something, and because the Lagrangian is a function of 4 variables, and so we can take a slope in like each of those directions. Okay, sorry, that's probably jumping too much.
Well, I mean, it evokes an image. I don't know what to do with that image, but it certainly evokes an image.
Basically, you're doing the same thing where you find the slope and you find where the point is 0, but because you're not just in like a flat plane anymore, you're in like a space, like 3D space, or even more dimensions than 3. You have to find more than one slope.
Okay.
Right, like you could kind of imagine if you had like a 3D object and you're trying to find like the maximum of a 3D object, you don't just find the slope in the x direction. You also have to find the slope in the y direction. They both have to be 0 to find the maximum of a 3D object.
The maximum of the 3 objects distance from whatever.
Like
three-dimensional origin. Okay.
Exactly. Yeah, like its highest z value, like its highest point in the z direction.
I see. So if it's like a football or something, you don't just say, how far, like, and you're measuring from like the center of it, I guess. You're asking how far up and how far out.
Tuesdays is proudly supported by Modern Money Lab, an organization founded by economists Stephen Hale and Phil Lawn and activist Gabby Bond. Modern Money Lab and Torrens University are running online graduate courses in MMT and ecological economics from September this year. You don't have to have a conventional economics degree to apply, and if you're interested, Stephen and Gabby will be happy to answer all of your questions.
Hi, my name's Gabrielle Bond and I'm here with my friend Stephen Hale. You might remember us from our show on KRTD Media, Modern Money Donuts.
We're proud sponsors of KRTD Media. We'd like to tell you about our global online courses in modern monetary theory and ecological economics. They start this September. They're unique as far as I can tell. I don't think there's anything like them anywhere in the world.
If you want to find out more, you can visit our website www.modernmoneylab.org.au.
To find out about the courses, go to www.modernmoneylab.org.au.
Here, I've got maybe I'll stop sharing for just a second here. I've got my Joan Robinson mug here.
Yeah.
And if you can read that, this is a famous Joan Robinson quote, and it says, the purpose of studying economics is to learn how to avoid being deceived by economists.
Yeah. I've heard that before. That's great.
So let's say this is our 3D object, and we're trying to find like the highest point in space on it. Where is the maximum of this object? Right? It's clearly like here somewhere, right?
Yeah.
Or maybe if we hold it this way, it's like up here. Here's the highest point, right? And so because this is a 3D object, it's got a slope in this direction, and it's also got a slope in this direction. And they both have to be flat for this to be the maximum of the object. Like if we were over here, if we were looking at this point right here, its slope would like be like this, right? It'd be like pointing up. It would not. So that's not the maximum because its slope's not 0, right?
Yeah. Even though it would be flat on the other side.
Yeah, exactly. Even though like, it might be flat. Yes, exactly. So you have to do the same thing in every direction that you've got, basically.
All right, cool. All right, that conceptually makes sense, and I trust that there is math happening that will punch out the number when it's time for that to happen. All right.
So basically, these 3 lines here, and then also this 4th one over here, is trying to do just that. Like the Lagrangian turns out to be a function of 4 variables, and what that means is the individual can choose 4 things. They can choose how much milk to consume. They can choose how much money they want to end the game with. They can choose their net demand, which is like how much milk do you buy. Remember, this is like, I'm going to get 3 more units of milk than I have. So your net demand is 3. And then they can also choose this SG, how much milk they sell to the government. So those are the 4 things that the agent in this model can choose. And so the Lagrangian is a function of all 4 of them. And so to maximize utility, we're going to do this procedure with all 4 of those. We take the derivative of the Lagrangian. So here's like the derivative with respect to C. This is like the slope of this thing, but in the direction of how much milk we consume. And we do that for the other 3 as well, and we set them to 0. We try to find what values of the variables make the slope 0. And those are going to be the optimal choices. The optimal choices for how much milk to drink, for how much money to have, for how much to sell to the government, and so on.
I see. Okay, so that's why you have this variable called partial, because it's taking a derivative of only a portion of this object. Okay.
Yeah.
You do it 3 times, one for each variable in the object.
Exactly.
Okay.
And so like the first one, I'm not sure it'd be worth it for me to go into exactly what's going on in these lines, because it does require some calculus, like to know not just what the derivative is, but how to take it, like what mathematical operations you have to do. So it might just be better for you to trust me on that.
Yeah, for now, I'll trust you on that, because we're about 90 minutes in, and we're still on the first model.
Okay, so yes, that's the procedure that's going on here. You do the math, and here's kind of what happens. Like, the upshot of most of this is that, for one thing, to maximize their happiness, the agents are going to choose V equals 0, which means they're going to choose to end the game with no money. And the simple interpretation there is like, why would you end with money that you could have spent to buy milk and drank more milk?
All right. Can you put into a sentence the equation at the beginning of that line, since mu equals u prime of c over pf greater than 0?
Yeah. Well, this second line here tells you that either you have to end the game with no money, or else this mu, which is the Lagrange multiplier right there, it's one of these shadow prices, has to be 0. And then here what I'm showing is that it can't be 0, because mu turns out to be equal to this ratio, and this ratio must be greater than 0. And so if mu cannot be 0, then V has to be 0. So okay. That's, I don't, the intuition on exactly what this expression means is probably would take us way too much time. But the upshot is that agents choose to end the game with no money, because any money they have, they try to spend it to buy more milk, because milk is the thing that makes you happy, right? Like the utility function here is only a function of how much milk you drink. It's not a function of how much money you have. And so if you can get rid of your money to get more milk, you want to do that.
Okay, all right. Now that makes sense, and I'll trust that the calculus works itself out. Anyway, so agents choose to end the period with no wealth. They want to spend all their money so they can buy their milk and drink it and be happy.
Yeah. Okay, and then so we had the Lagrangian. We take all these derivatives, right? We're finding all the slopes. We're trying to find the values of the variables that make the slope 0 so that we can maximize our happiness. And when you try to do that with the last one, which is the choice about how much milk to sell to the government, what you find is something very interesting that I then spend the next 3 paragraphs here describing. And what you find is that this expression, this is like that slope, and we would like it to be 0. But it turns out that the value of the slope depends on the prices only, and doesn't depend on the choices that we make. And so there is nothing you can do to make this 0 if it wasn't already. And so here's the upshot of this. What that means, translating that back into something more sensible. If the government's price and the private price are equal, then you are actually completely indifferent about how much stuff you sell to the government. So far, based on what we've got so far.
Right.
Any value of that will be fine. On the other hand, if the private price of milk is below the government's price, then what you want to do is actually sell as much milk as you possibly can to the government. And the reason that you want to do this is because you're going to buy milk in the private sector at this price, PF, and then sell it to the government at this higher price, PG. And so you're making money from doing this. It's an arbitrage profit, right? Yeah. You buy milk at a low price, sell it to the government at a higher price. And so if the prices are like this, where the government's price is higher, then what you want to do is buy as much milk as you possibly can and sell it to the government, sell all of it to the government.
I think I understand the logic, and I'm starting to understand sort of like how the math is working out. So this partial L over partial SG, the slope of that, the only independent variables that go into that are the prices paid by the government and by the private sector. Mm-hmm. Meaning that, when they're equivalent, the slope is 0, which is your maximum, right? But then when the private price is lower, then the slope is always positive because it's PG minus PF, and you're not worrying about anything else, any of the other starting variables. So you have a constrained choice here.
Yeah, and if the slope is always positive, then the way you maximize the thing, it's just like you keep moving farther and farther to the right. Right? Like if the slope is positive, then it's like a line that's sloping upward. What's the maximum value? Like, where's the maximum value of the line? Well, there isn't one. You just keep moving to the right and it just keeps getting bigger and bigger, right? And so that's what this is saying here, is like if this slope is positive, then you want to choose the biggest value for government spending that you possibly can. You want to sell as much milk to the government as you're able to get away with.
I guess each individual agent wants to do this.
Yes.
Right, but I guess but if the utility is primarily a function of consumption, then at what point are they selling milk that they should have drank?
Well, what you can do is let's say that you want to, you want to sell. I've been stressed. I guess I've been saying you want to sell as much as you possibly can, but that's not quite right. Let's say you decide you want to consume, some amount of milk. You want to buy everything. Oh gosh, this is hard to put into words. I'm sorry. What you want to do is buy as much milk as you possibly can, sell it to the government, and then you just made some money. And then you use that money to buy milk that you then drink.
Okay.
Now, the part of the issue is if the government is always willing to buy all of the milk, then there's almost no limit, right? It's if you could just get milk from somewhere, if there was no limit on how much milk existed, then you would never stop, right? You would just keep selling it to the government and you're making more and more money and you're I'm going to use this money to buy milk at some point, but you make an infinite profit.
Yeah. I imagine the other constraints in the Lagrangian deal with this in terms of the initial endowment of milk.
Yes, exactly. And I don't even really bother to get into that because what I'm going to say a little bit further down here, if you scroll down just a little bit, is that this case where the government's price is above the private price is not consistent with the private market being balanced, with supply equaling demand in the private market. And that's because every single person is trying to do this same thing, where they buy as much milk as they possibly can in the private sector, and then they sell it to the government. And if they're selling it to the government and not to the private sector, then so nobody's selling anything. Nobody wants to sell anything in the private milk market. People only want to buy, so that they can then sell to the government. And so you have this situation where the demand is just always greater than the supply. And so that should push the price up. And so if you were in this situation where the private price was less than the government's price, this would very, very quickly be rectified by this imbalance issue, that everyone's trying to buy in the private market and nobody's trying to sell in the private market because everyone's trying to sell to the government. And so that pushes up the private price until the arbitrage profit goes away.
Okay. That makes sense, because you'd have infinite buyers and no sellers, and eventually the price would have to end up changing.
Yeah, exactly. And so I just kind of say, like, this is just not, it's not even allowed, right? It can't be an equilibrium. And so we just basically rule this case out.
All right. Okay. So that just leaves you with the other two cases of PF equals PG or PF is greater than PG.
Yeah. So let's go to the one where PF is greater than PG. Okay. If you wanted to get into the slope, right? If PF is greater than PG, then the slope is always negative. So it's like a line that's pointing down, right? And how do you maximize the line that's pointing down? Well, it gets higher as you move to the left, so you want to move to the left. But here, there's going to be a distinct limit, right? The low, so move to the left means sell less stuff to the government. And the least amount you can sell to the government is 0. So I guess you can think of what's happening here is if the private market price is above the government price, then if you've got milk to sell, you would rather sell it in the private sector because the price is better. And you would not choose to sell any to the government.
All right, that makes perfect sense. So if the private sector price is higher, you don't want to sell any to the government, and if the private sector price is lower, you don't want to buy any from the private sector.
No, you do want to buy from the private sector so that you can sell it to the government.
Right. We're sorry, you don't want. No one else wants to buy from you.
Nobody wants to sell to you.
Okay.
If the government's price is higher, then everybody wants to sell to the government instead of to you.
If the government's price is higher, everyone wants to sell to the government instead of to you. And if the government's price is lower, then no one wants to sell to the government. Is that how am I getting it right?
Yep, that's exactly right. This is about sellers of milk, and people want to sell wherever the better price is.
Yeah. Okay.
So this table here just captures what we just said. If the government's price is higher, then you want to sell to the government, and you want to actually buy from the private sector and then sell to the government to make that arbitrage profit. And so maximize the amount you sell to the government. On the other hand, if the private price is higher, then you don't want to sell to the government. You want to sell to the private sector, better price. And so the minimum you can sell to the government is 0.
All right.
If the two prices are equal, then, somewhere in that range, right? You'd be okay with selling like just some number to the government that maybe is 0, bigger than 0, somewhere in here. It doesn't, right? That if the prices are equal, that's all fine. That you don't have this like arbitrage issues to worry about.
Okay.
Okay.
But then later on, we say that first one is actually ruled out. At least the buying from the private sector is ruled out.
Yeah. So far, we've only looked at like what the agent wants to do. We haven't looked at like harmonizing what everybody wants to do together. Like, are those desires actually consistent with what's happening? We haven't looked at that yet. We've just looked at like, what would you do if you could do anything, basically. And, if this case existed, if the private price were less than the government's price, then what every single person would want to do is buy as much as you can in the private sector and sell it all to the government, and now you've made a huge profit, right? That's your arbitrage case. And now what we go ahead and say is, well, not everybody can do that, right? Like, if that were happening, then everybody's trying to buy in the private market and nobody's trying to sell, right? And so the market's out of balance. And so once we go in here and impose the requirement that the market balance, that supply equals demand, then this case just doesn't work. And so we have to say, well, it can't happen, right? If it did happen, there's all this demand and no supply, so it would push the price up, right? It would push the price up until until the private price is no longer less than the government price.
Okay.
So we effectively rule that case out. And then we turn to the other two, right? And specifically, we're going to look at this case next. What if the private price is above the government's price? And here's how we're going to get at what happens. So first, remember that we said that we have to end, the agent chooses to end the game with no wealth. You don't want any money, you want to spend it all and buy milk. Okay. And so what we can do is go back up here. This was our equation that, told us where the money went. We're going to stick a 0 in for this V, right? You want to end the game with no money because you want to buy the milk. And so this V is going to be a 0. This is how much money you end the game with. So we stick a 0 here. And then I think in the same line, I also solved for N. And so I added this term across to the other side of the equation and then divide by this PF here to get N by itself. And so after you do those two steps, that looks like this.
Yeah, that rearrangement I was able to do.
Nice. Okay, so we have this expression for N, and then we're going to say, if we look just at the private market, and we look at supply and demand in the private market, okay, if we were to take BF, so this is demand for milk in the private market, and then we have SF, this is the supply of milk in the private market, how much milk people are trying to sell. Okay, we can look at how much bigger is the demand than the supply? And this gets called excess demand. How much bigger is the demand than the supply? So we take this BF minus this SF, demand minus supply. And the reason we're doing this is because if the market is in balance, in equilibrium, if supply equals demand, then this excess demand should be zero. Because supply equals demand, BF equals SF, and so BF minus SF would be zero. So that's why we're about to look at this. We're about to see what does it take for this thing to be zero. But before we do that, we're going to mess with it just a little bit, because if we look at BF minus SF, you might notice that that happens to equal this thing here, N plus SG. And how do we see that? We can go back up here to the definition of N. Here's what N is. BF minus SF minus SG.
Mm-hmm.
And you can see that if we add the SG across to both sides, right? If we add SG and move it to the left side of the equation, we would have N plus SG equals BF minus SF, right?
Right.
And so down here, when we're looking at exactly that thing we just said, BF minus SF, that is equal to N plus SG.
Okay, got it.
And then we can take this N that we just figured out over here. This is not the definition of N, but this expression happens to be equal to N if V is equal to 0. And then we will substitute that in for N right there. So we'll just stick this first term in this equation here just comes from right there. This is N, and then we've got plus SG, right? Plus SG plus SG. And then here, all I'm doing is just simplifying this just a little bit. Right, like you pull this plus SG into this fraction by add a term in the fraction that's like plus PF times SG. And then that's going to cancel out this term right there and leave you with just that.
Okay.
Does that make sense?
Yeah, I can follow those steps. Yeah.
Yeah, this would probably be a little bit easier with the whiteboard, but hopefully you're getting it there. All right, so why, just to backtrack, why did we do this? What we're trying to look at is whether or not the private market is in balance, is in equilibrium. And so we said we want to look at the excess demand, the demand minus the supply. And if the market's in balance, then that should be 0 because the demand equals the supply. And all the several steps of rearranging we just did made it so that this excess demand, BF minus SF, is equal to this thing I've got highlighted here. And so what we want to know is, what does it take for this thing to be 0? When this expression is 0, that means that the private market is in balance. So now we go back to our little table here, and you know this table got copied over the page break, which really sucks. Like in the formatted version I looked at before I posted this, it was not like that. But then, like, I don't know when it got posted, it got broken up. So this is supposed to be one table.
I figured, yeah. That's super annoying when you gotta turn the page over again. But
Oh, sorry about that.
it's okay.
Okay, sorry. Let me just summarize one more time. We're trying to figure out, what does it take for the private market to be in balance? If the private market's in balance, then the excess demand minus supply, should be 0. The excess demand turns out to be equal to this thing right here. And so we want to know, what does it take for this thing to be 0? And what we're going to go do is we're going to go back to this case here. We're going to ask, in this case, if the private market price is higher than the government price, what does the excess demand look like? And in this case, if the private market price is higher than the government price, then the amount that you want to sell to the government is zero. Because if you're trying to sell milk, you'd rather sell it in the private sector at the higher price than to the government at the lower price. And so if this price has this relationship, then you're not going to sell anything to the government at all. And so we're going to take this information and substitute it in here to our excess demand. And when we do that, we get this fraction here that it won't let me highlight properly. There we go. And remember, this is the excess demand. For the private market to be in equilibrium, in balance, this object has to be zero. And it's pretty clear that this thing can only be zero if V naught is equal to T. Meaning if you start off the game with V naught is how much money you start with, and T is how much you owe in taxes, if you start off the game with exactly how much money you're going to pay in taxes, then this expression can be zero.
All right, and if that expression is zero, then for the private market clears and there are no sales to the government.
Exactly.
Okay. So you can only have a situation in which the private market totally clears and there are no sales to the government if the amount of money at the beginning is equal to the tax burden.
Exactly.
Because otherwise there would be at least some sales to the government by definition, and the private market therefore wouldn't clear because there would not be the I guess like the funds available to purchase whatever the desired net demand of milk would be.
Yeah, you got it.
Okay. Oof. All right.
So it's like if you don't start off with enough money to pay your taxes, then you got to get some, and it comes from the government. And so the private market, if you don't sell anything to the government, then the private market cannot clear, right? Because people are trying to sell milk. More people are trying to sell milk than there are trying to buy the milk, because everyone's trying to get money to pay the tax. On the other hand, in the opposite case, in this particular setup right here, if there was more money than you needed to pay your tax, then everyone is trying to get rid of the money, right? Because they want the milk.
Right, right.
All right, so what we end up saying here is that we kind of like said, what if the private price were bigger than the government price? Well, then nobody would sell to the government. And if you didn't have enough money to pay your taxes already, then this becomes a mess, right? Like not having enough money to pay your taxes at the beginning, V naught less than T, is inconsistent with PF greater than PG, with the private price being above the government price. Because then nobody sells to the government because everyone sells to the private sector, but also there's no way to get the money you need to pay the tax.
Okay.
And so, yeah, you'd have this excess supply of goods, people trying to sell milk to get money to pay the tax would drive the private price down until it's equal to or less than the government's price. And so what we've just done is we had all three cases from this table, and we kind of looked at them and we said, well, there's nothing really wrong with this one where the prices are equal, but there is something wrong with both of the other ones. Both of the other ones cause a problem, like things start breaking. And so we basically conclude that they don't happen, that the only like stable state, equilibrium value for this model has to be this case here. It's like almost like a proof by contradiction.
Yeah, yeah. So in the case of single good markets where the government buys, an unlimited amount at a fixed price, where there is a net tax burden and the private market clears, the private price will converge to the government price because if it were higher or lower, either the markets wouldn't clear or people would not be able to pay their taxes.
Yeah. And so one way to think about it is the government can bring any price up by buying the thing. They can always buy more of something, and so they can always bring the price up by offering to pay more for it, right? Because they don't run out of money. And so they can always bring any price up. They can also bring all prices down by taxation. If there's taxation, then people have to sell stuff to get the money they need to pay the tax. And so that pushes prices down. And so you've got these two things. The government can bring up any price up by selling more stuff. Bring any price up by buying more stuff, and they can bring prices down by the tax mechanism if there is a net tax obligation, as you put it. Then those are the two things that push the private price to be equal to the government's price.
All right, cool. Let's go on to the next page, and then
So kind of
it sort of summarizes what we said, right?
Yeah, exactly. The sort of conclusion here is that the government's price, the market price, comes to equal the government's price if the tax is greater than the amount of money you start with. If you need to sell stuff to the government, then when the dust settles, the prices are equal to each other and equal to the government's price. Phew, there's not a lot.
All right, cool. So we went through the single period model in detail, going through all the rearrangements that did not require too much calculus, although we got into a little bit of calculus and talked about Lagrangians and four-dimensional objects.
Yeah.
Now, it could be beneficial to go through some of the other models, perhaps in less detail. Now,
The good news is that most of them, a lot of it carries over.
Okay.
Yeah.
I will let you be the judge of the best way to use our last, the next hour. We can either go to the second half of the paper and talk about what happens when there's a government spending limit, or we can talk about these multiple period models, or just try to do it all. What do you think?
I think maybe the thing to do is go to the multiple period one, and maybe to keep things as simple as can be, I will sort of go mostly straight to the 2 period one. Okay, well, here's what I want to get to. These graphs here, I've got like a little interactive version of these that you can, move the sliders and the curves move. And I think that helps build intuition about what's happening in the model. So I'd like to get there. And we don't have to go through like all this monstrous algebra and stuff. And so I guess I'll talk for just a couple minutes about the sort of general what's going on in the multiple period model. And then we'll go to the 2 period version. Is that all right?
Yeah, sounds good to me.
Okay, so in the multiple period model, you've got like all the same stuff, except there's multiple periods. Like the game happens again and again, and you carry over, money from period to period. If you end period 2 with $10, then you start period 3 with $10. There's only money. There's no like, bonds or stocks or any other assets. There's no interest. And this is in the tradition of keep the model as simple as you can possibly make it, just to get whatever the minimum you need to get the point across. So that's what I'm trying to do here. So no interest, no bonds, stocks, any of that. You also, the only thing you can store across time is money, because, it's still some consumption good that doesn't store. So it's like milk, it spoils. And then the other change is that when the game lasts multiple periods, your happiness is not just based on how much milk you consume in one period, but it's based on how much milk you consume over the whole entire game, like your whole life, right? And so you might do some kind of trade-off where you consume less milk now if you can consume more later, right? And these are the kinds of things you can think about if the game lasts multiple periods. And mainstream economists love this stuff. Like if you take like a graduate level mainstream micro or even macro course, it's like this is all over. This is called intertemporal substitution. So intertemporal means like across time. So like, if I have, maybe I'm in a situation where like the game lasts 2 periods and I've got a total amount of milk I can consume across both periods is 10 gallons. But then I get to decide, do I want to, is I want to split that up like 5 and 5 or 6 and 4 or 4 and 6, right? And there's these different combinations, and you pick the one that brings you the most happiness. You have some preference about this, about how much you prefer to consume milk now versus later.
Okay.
So that's what goes on in these models. I'm not going to go into the math too much, but you will kind of notice that like here's our Lagrangian, and it's got a lot of similar stuff in it. There's some slight changes. Here's the utility function, and now instead of it being just based on the one time you drink the milk C, we've got like the consumption in each period. How much milk you drink in period 1 and period 2, et cetera, et cetera. Those all affect your happiness. And then we've got the same, like here's our constraint. Here's a Lagrangian multiplier. Here's the other constraint. Lagrangian multiplier. So that stuff's all the same. But then what we're doing is we're going to sum this up for every time period, because we don't just have these constraints once, we have them in every period, right? Like the milk that you drink in period 4 had to come from somewhere in period 4, and same with period 5 and 6 and 7. And so there's like not just 2 constraints now, but 2 constraints per period. And then you do the same procedure. You take the derivatives, set them equal to 0, and like figure out what that tells you about how much milk how much you want to sell to the government, how much milk you want to consume in period 6, whatever, all that stuff, how much money you want to have carry over from period 10 to period 11, and so on. You get a bunch of equations that describe all that stuff. And kind of the key equation it's called the Euler equation. Euler, like the mathematician, not Euler, but Euler. And so I once saw somebody call these I think it was Noah Smith maybe, called these equations like the flux capacitor of modern macroeconomics. That like every macro model has one of these things, and it's the thing that makes it go.
What are your thoughts on that?
Well, even in that article, Noah Smith was saying these things suck. And he talked to some big important macroeconomist who was like, the next generation of macro models should find a way to replace these because they don't work. Like you can make the math happen, but like they don't describe what real people do. What this equation does is it describes your intertemporal choice. And again, this is like, if I've got 10 gallons of milk to consume in periods 1 and 2, do I do it 5 and 5? Do I do it 6 and 4? Do I do it 7 and 3? That's like your intertemporal preference. And the sort of mechanism that these use kind of assumes that there's like an incentive system here. So this is like, if interest rates are higher, then what should you do? Well, one story that this logic would support is like, if interest rates are higher, you should save more now. Because if interest rates are higher, that just means you can consume more later, right? I save $100 and maybe interest rates are like 20%. And so next year I have $120. And wow, I'm getting paid a lot of money just to save, so I should save. And then I can consume more later. On the other hand, if interest rates are low, then, I'm not getting paid a lot to save. I should consume more now. If interest rate's only 1%, I got $100. I'm only going to have 101 next year. I'd rather like consume more now. And so through these kinds of mechanisms, it affects like how you want to when you want to do your consumption. Do you want to do it now or do you want to do it in the future? According to like basically how much you value the present versus the future and the interest rate. And the reason that...
Oh, go ahead. I was going to ask why you think these don't work, but...
Yeah, the reason that they don't work is because that's not how real people behave. In fact, in a lot of cases, real people do the exact opposite of that, which is like, if interest rates are higher, the interest rates as incentive story would say that if interest rates are higher, you should consume more in the future and consume less now. But actually what happens is, when interest rates are higher, people actually save less now. They consume more now. And the reason people do that is because when interest rates are higher, it's easier to hit like some target savings goal you have. Right? If what you're saving for is like so that your kid can go to college or so that you can retire, and maybe you've got some explicit numerical target that's like, I'd like to have $1 million in the bank by age, whatever. Well, if interest rates are higher, it's actually easier to hit that target. And so you don't need to save as much right now. And that's like the exact opposite of what happens in the Euler equation, in Euler equations. But anyway, they're in mainstream models, and this is all about doing this stuff with mainstream stuff, and so we got one, right? So, it's a mess, but here it is. Okay.
Oh, that looks familiar. That very last line.
This one?
Yeah.
Yeah, so this is the same thing as, from back up here, as this. Exact same thing.
Yeah. Again, showing that the amount of sales to the government should be entirely decided by the difference between the government price and the private sector price.
Yep. That all carries over. Really, the main thing that changes is this Euler equation, that we didn't see that before. But everything else basically carries over. And then when I kind of what I do here, the logic that I step through, and I'll just go real fast, is like, we kind of again ask, what is the relationship of these two prices? What values can they have that make sense? And so we again look like, can the private price be less than the government price? Can the private price be more than the government price? We go through those two cases. And really quickly, the case where the private price is less than the government price actually has the just exact same problem. It creates this arbitrage opportunity, and so the market can't clear, and so that should always push prices up. And so this can just never happen. We can just never have any period where the private price is below the government's price.
Mm-hmm.
Because the market can't clear. That we can't have supply equaling demand in the private market. So we rule it out, same as we did before. The other case, if the private price is above the government's price, is a little bit trickier in the multiple period model. And the reason is, the way we were able to rule this out before was by saying, if this were the true price relationship, then nobody would sell to the government, because they would sell to the private sector instead of the government, because the private price is higher. But you have to sell to the government to get the money you need to pay the tax. And so in the one period case, we just said this can't happen either.
Mm-hmm.
In the multiple period case, it can happen, because you might need to sell stuff to the government to get the money you need to pay the tax, but you don't necessarily need to sell stuff to the government in every single period.
Because you might have money left over from the previous period.
Exactly. Maybe in the last period you sold, twice as much as you needed to the government, and then you pay the tax, and then you keep some of the money and you use that to pay the tax this period. So this period you don't need to sell anything to the government.
Right. I also remember that I think you allowed the private sector to borrow in this particular version of the model. Does that also complicate?
Yeah, there is a little bit of complication there in that the private sector in this version is allowed to borrow from the government. And so the amount of money you have can go negative.
Okay.
But what I get into here is that it can go negative, but not permanently negative. Like at some point, what actually it's like this line here. This line here is saying that at some point in the distant future, you have to repay the government.
Mm-hmm.
And so the kind of upshot of all this is, in any individual period, this might happen. The private price might be above the government price, because you might not need to sell to the government because you might already have the money. Or maybe you don't need to sell to the government because you're just going to borrow from the government. You just let your money go. You pay the taxes and then your money goes negative.
Mm-hmm.
But as long as at some point in the distant future you have to repay the government and you have to pay the tax, then this cannot be true every period. The private price can't be above the government price in every period, only some of them. So in at least some periods, this is what I kind of show here, in at least some periods, the two prices have to be equal. And because it's like an infinite game and you have an infinite amount of taxes to pay, it actually turns out that the two prices have to be equal in an infinite number of periods, which I know is like some mind-bending logic.
It's just a larger infinity than the other one, right?
Yeah, exactly. Yeah, you nailed it. Okay, so I'd say that's what's going on in the multiple period model. That's kind of the ins and outs, right? So broadly speaking, you as a private agent, you have so much milk that you're going to be able to consume, and that is based on how much milk drops from thin air minus the amount of milk you need to sell to the government to get the money you need to pay the tax. And so over the course of the game, that's some amount of milk that is like available for you to consume. And then you get to choose when you consume it by choosing when you sell stuff to the government. You have to sell stuff to the government to get the money to pay the tax, but you could choose to sell them more stuff now and less stuff later, or less stuff now and more stuff later, and that's up to you. And that affects, what prices happen when. And so in this next section here, I kind of figured I was getting too abstract and we should do a little more concrete version of it. So that's what we're doing here. So We got time for this?
Yeah.
Okay. So I did try to add this paragraph here that's like how you can like sort of think a little bit more realistically about what's happening here, like just a little frame story. So we're like imagining that a special district government just formed, and they only formed to perform some short-term project, right? Maybe they're going to build one bridge or something, and after the bridge is done, they're going to disband. It's just like a special district. And this government has been granted the power to issue its own currency and levy taxes payable only in that currency. And here we're saying it's a 2-period game. So maybe the project's going to last 6 months, and taxes have to be paid in 2 rounds. The first time is 3 months into the period, and then at the end of the 6 months, you got to pay taxes again, and then the government stops existing. Right? Mm-hmm. So people have to sell, labor and stuff to this little government to get the money they need to pay the tax. But you also don't really want any of the money after the government disbands, because you're like pretty sure it's going to be worthless, right? Like maybe you want to collect a few just for historical keepsake. But if actually you don't care about that and the only thing you care about is drinking milk, then you don't want any money at all after the game is over, because it's going to be worthless. So you want to sell it all to get milk, right?
Mm-hmm.
So mathematically, here's what we do. Let's assume that you don't start the game with any money. So we'll just say your initial money is 0. Just keep things simple. And now we're going to give an explicit form for the utility function. And there are all different kinds of things you could stick right here. This is just a mathematical expression that tells us how milk translates into happiness, right? So like, here I've just sort of arbitrarily chosen to say like, how happy are you? Well, it's the logarithm of however much milk you consume in period 1 plus some number beta times the logarithm of how much milk you consume in period 2. And I know this is like abstract and arbitrary as hell, but it's also a very common way to do utility functions that you'll see in mainstream papers. So mainstream people seeing this would be familiar with this, even if it sort of makes no sense if you're not, steeped in economics. And the reason that they pick this particular form is because it turns out that like it's very easy to take derivatives of logarithms. So when we take the derivative of this later, because that's what we have to do, it's going to give us a nice and neat result.
Okay, yeah. And beta is some coefficient that represents the utility lost from delay, or?
Yeah, that's exactly right. So beta it's like a number between 0 and 1. And it determines like how you value the present relative to the future. So It's sometimes called a discount factor that's telling you like, if beta were equal to 1, then this u would be like perfectly symmetric between C1 and C2, right? It would just be log C1 plus log C2, basically saying like you care about the present and the future equally as much. On the other hand, you can imagine if beta were 0, then this whole second term would just go away. And so the utility function would only depend on the consumption in period 1. If beta were 0, that's like you don't care about the future at all. You only care about the present.
Right.
And so anywhere between 0 and 1 is like a mix, right? You care about the present and you care about the future. Like you still care about it, but you care about it a little bit less than the present.
Okay.
So that's what beta does. And again, this is a standard thing in mainstream econ that you would see in a mainstream paper. Okay, so the total amount of milk, there's 2 periods to this game, and you get y gallons of milk every period, so the total amount of milk is 2y.
Mm-hmm.
And then you have to pay t in taxes every period, and there's 2 periods, so the total amount of taxes is 2t. And that's in money. And so that means you're going to have to sell 2t divided by pg units of milk to the government. So the government is paying pg per, per unit of milk. So this is how much milk you have to sell to the government to get enough money to pay the tax the total tax you owe over both periods.
Okay, so this part I did follow. I wrote down that the total amount consumed is the starting amount minus the amount sold to the government.
Exactly. And so you take this equation here, and this you can actually plot this equation. This is the equation for a line. What you do is and it's right here, you put C1 on the horizontal axis here, C2 on the vertical axis, right? And you could take this equation and you could just solve for C2, let's say, subtract C1 across, and you get an equation for a downward sloping line that looks like this. Now, the reason that the line is cut off like this is because we have to start thinking about, well, there's a limit to how much milk you can consume in a period. Right? If there's only one I keep trying to use the number 10 here. So let's say that Y is 10. So you just get 10 gallons of milk every period. If there's 10 gallons of milk in a period, then that is the most you can consume. You can't consume any more than 10 because it doesn't exist. There's no more milk to drink, right? Mm-hmm. And so the farthest to the right that this can go, the most milk you can consume in period 1 is Y, right there. And kind of symmetrically on the other side, the most milk you can consume in period 2 is also 10, because it's your 10 gallons that you get in period 2. You can't drink any more milk than that because there's nowhere for it to come from. And so we impose the maximum there as well, 10. We can't go any higher than here. The red lines here correspond to if you plug this value Y in for, C1, then this would be the value you get for C2. This is the total amount of milk you have to consume. So let's do it like this. Let's say the total amount of milk you get per period is 10 gallons. So the total amount over both periods would be 20 gallons.
Okay.
And maybe you have to pay what amounts to 2 gallons of milk in taxes each period. And so the total amount of milk you have to sell to the government is 4 gallons over both periods.
All right. Makes sense.
And so then the total, if this first number is 20 and the second number is 4, then the total amount of milk you can drink across both periods would be 20 minus 4, 16.
Okay.
And so this is saying, if you choose to consume 10 in period 1, and your total for periods 1 and 2 has to be 16, then if this is 10, then this number has to be 6.
Oh, okay, that makes sense.
Yeah. And it's symmetrical over here. And I do have a thing for this. So let me see. I think it's here. Okay, so let me turn stuff off here. So we're not looking at the wrong thing. Okay. Yeah, let's see. Oh wait, I'm missing something. That. Yes, here's that graph we were just looking at. So you can see we can adjust. Let's see, what should we adjust? I think this number is, rats. The amount that has to be sold to the government. Right, okay, sorry, wait. Fix one more thing. There we go. Okay. So this slider is moving those red lines, right?
Mm-hmm.
This is showing that this slider is how much you have to pay in taxes. Okay, and if you didn't have to pay anything in taxes, then you would consume 10 in both periods.
Right. Okay.
On the other hand, if you had to pay, let's see, let me make sure I don't mess this up. Yeah, if you had to pay 10 in taxes, am I doing this right? Then you could consume 10 in one period and 0 in the other. Or you could consume 10 and 0 in period 1 and 10 in period 2, or anywhere in between. Okay, so to clarify that a little, what's happening here is you use the sales of milk to the government to shift around when you get to drink the milk. So the total amount of milk you get to drink is 16.
Mm-hmm.
And you could do that you could consume 8 and 8, or 10 and 6, or 6 and 10, right? You've got 2 periods, so 2 chances, and they just have to add the 16. And so if you wanted to consume, let's say you wanted to consume 12 in the first period and 4 in the second. So that's not possible because the amount of milk you get in the first period is 10, so you can't drink 12. There's just nowhere for the other 2 to come from. But on the other hand, if you wanted to drink 10 gallons in the first period and 6 gallons in the second period, you could do that. You would sell nothing to the government in period 1. You would just drink all 10 gallons that you get. And then you would sell 4 gallons to the government in period 2 and drink the other 6.
Okay. All right. I think I understand all the various combinations and why there's a maximum.
Okay. So then, oh boy, here we go. So then this is another device that's standard in mainstream economics. It's a thing called an indifference curve. Okay, so we're looking at this blue curve here, and I think I've actually got, it's like in here. There's one. So what this curve is showing you, and I'm moving it around here, but what the curve shows you is a set of all points that make you equally happy. Okay, so like if we pick a point on this curve, this point is showing us if you consumed, maybe let me try to get a slightly rounder number. If you consumed 6 gallons of milk in period 1 and 2.244 in period 2, that brings you some level of happiness. That happens to be the same level of happiness as if you consumed, let's pick a different point on here. 3 gallons of milk in period 1 and 4.488 gallons of milk in period 2. Those bring you the same level of happiness, so you're indifferent between those 2 combinations and any other point on here. All of these are combinations of, you could split the milk up in different ways, and these all would make you, all the points on this curve make you equally happy.
Okay, yeah, that makes sense.
So then what we have, though, is if you could just get more milk total, right? Like, let's say I move the curve here. This curve actually makes you happier than this other one did. On this curve, you've got more milk in both periods. And so you're just overall happier than you were in the previous one.
Right.
So that's kind of how indifference curves work. You would spend a bunch of time on this in like a, upper division microeconomics class. And so then what you do here is the black line is showing us the most amount of milk that we can drink. And so the happiest we can be is when we find the indifference curve, the blue curve, that is the farthest out it can be, but still touching the black line. So like right about there, sort of here. Because you want to be, the farther out the indifference curve is, like the more this way, the farther out the indifference curve is, the happier you are. But because you're constrained in how much milk you can drink by the fact that, only so much milk exists and you got to sell some to the government to get the money to pay the tax, you can't, these curves out here are like not attainable. If the curve is in here, you could do that, but then you'd be throwing away some milk. If you drink more milk, then you're moving like this way until you hit this black line, this constraint, where you can't get any more milk.
Okay.
And so to maximize your happiness, you want to find the utility curve that touches the black line in just one point. Phew.
Because
this is how mainstream economics works. This is like what mainstream economists spend their time doing.
This is very complicated. I mean, conceptually it makes sense, but making the equation seems like it very complicated, and also what was the phrase we started to say earlier, where you talked about sort of like how people don't necessarily rationally behave this way.
Yeah. You have this whole issue of like these models predict a certain kind of behavior that in a lot of cases people do not do. And that the reason I think people there's this whole debate about whether people are rational or not, and I cannot stand that debate. It's like economists were saying people are basically rational, and then you've got psychologists and behavioral economists who are like, no, people actually aren't rational. They do. I just think that the whole debate is just screaming nonsense. The problem is not that people aren't rational. The problem is that the economics definition of rational is insane.
So you had a little tweet about this earlier. I didn't get a chance to read your explanation, but I saw that you began a kerfuffle. You started one. So you care to elaborate?
I'm not sure which thing you're talking about.
I feel like you tweeted at some point exactly that, like the economics definition of rationality is insane.
Oh, you know what? That was Nathan Tankus.
Oh, was it Nathan? Oh, okay.
Yeah. And he's right. I completely agree. And he phrased it very nicely. It's that, first of all, the real world situations that people are in look nothing like the situations in these models. And that's issue one. Like the real world situation you're in is like much more complex, and you know way less about it. Like you just have no idea what's going on. Like for a while, and still mainstream economists got into this whole like mode of thinking that had just all this like reflexivity in it. And what I mean by that is like the people in the model like know that they're in a model, and they know how the model works, and they use their model of the model to make decisions. And then other people in the model know that the people in the model have a model of the model. And so they, it's like, I know that you know that I know that you know, right? Yeah. It's like that kind of thing going on. And that's because if what you're trying to do is optimize, and if what you have is like a lot of information about how it works, like how the model works because, somebody has designed it, and then that's very simple like that, then sure, maybe people would be doing things like that. But in the real world, like we don't have goals that are as clear cut and defined. And we're in much more complicated situations that we just basically have no idea what's going on.
So how would this model change if you put in like something that would from the real world that would complicate it? Maybe an example would be like, precautionary savings. Like what if people what if people know, or rather, what if they think that the tax burden will go up in the second period, but they don't know by how much? Like how much would that complicate the model?
Yeah, so what it would do is it would like affect when people want to sell to the government, right? And so I think this is where it starts to get a little real, is because what people want to do is they want precautionary savings. And so you want to earn money now that you're just going to hold on to. And so in this story, right, the way that works is you sell stuff to the government to get the money that you might need to pay taxes later. And so that I think is very real. And mainstream economics, they're not blind to precautionary saving. There's actually been a lot of work in the last like 2.5 decades, maybe, of them starting to work more formal models of precautionary saving and using these same techniques, optimization and Lagrangians and all that kind of stuff, to talk about when people have like target levels of savings. But like, it took them decades, right? Mm-hmm. To be like, maybe people have target savings. Actually we can manipulate the crap out of our models to get people to do that. And it's interesting that those models with target savings behaviors are actually like mathematically incredibly difficult. They turn out to be just even a lot more sophisticated than what I'm doing in this paper. And the thing that the moral of the story at the end is like, people might have target savings. And it's like, I don't think we needed this really sophisticated model to tell us that people have savings targets. I think we could have just asked people that. We could have just like been like, I do that, and gotten that answer much faster. But like it wasn't legitimate until, in the 1990s, they came up with a version of this utility maximization stuff that says people have savings targets. Then it became legitimate, and so that's exactly what I mean when I say like these things are gatekeeping devices.
So did they have to like derive from a standard model, like a motivation for them to have precautionary savings, or did they have to put precautionary savings into the model and prove that the model still functioned?
The first one, they were able to derive precautionary savings from certain stipulations about the utility function. It's like if the utility function has a certain shape, and if there's like a certain probability, if like your income's uncertain, so that, whatever. And then there's like one or two more conditions in there, then people have precautionary savings behavior if you're trying to maximize your utility.
All right. What is an empirical assumption that you think they haven't figured out how to derive from their models that you think needs to be part of their understanding, like currently? Because you said that they're starting to figure out precautionary savings. What have they not figured out?
I think one thing they haven't figured out is that markets don't clear. Every single model is based on, not every single, but the vast majority of models are based on market clearing. Just assumes that supply equals demand. And when I look out in the world, supply never equals demand. Like you go to the store and there's a large pile of food on the shelf. And the price doesn't go down because of this. Right?
Yes.
You'd think it would. Supply is bigger than demand. Shouldn't the price fall? It doesn't, though. Right? And also the labor market. They're better about this than they used to be. They used to, like 50 years ago, economists would say, like, market's always clear. Today, they would say, well, maybe in the short run, there's some issues. There's like sticky prices, or there's like some information frictions where it's like costly to, it's like you got to find the right worker, but that's costly and you can have some matching problems or something. But in the long run, it works itself out.
Would it even be possible to solve a model if you stipulated that markets never cleared?
Yeah, because what you do is the price just can't be dependent on that. So like when post-Keynesians make macroeconomic models, they don't have market clearing. Like you have capacity that's just greater than actual demand. So you've got some spare capacity or reserve capacity. And so like they'll use something called a utilization function. It's like capacity utilization. How much of your capacity are you actually using? And that might affect your decision making. So like maybe if your capacity utilization is really high, you're running your factory at like 95%, you might say, well, this is too high. Like we're running too hot. We don't have maybe there's like a certain amount of headroom that we want to have. Just like we only want to run the factory at like 90% on average or 85% on average, so that if there's some spike in demand, just for some reason, we are able to meet it without a problem, right? And so if capacity utilization gets too high, this is a cue that we need to invest more, something like that.
Okay, and you would have like some sort of like target capacity utilization, sort of as a precondition, I guess as like a condition of the model or whatever, and then it would
So,
I don't know, would it be what is would it be like a stepwise function? I feel like, I don't know if that's the right term for it, but like where the actual amount of capacity invested in is flat until it hits a certain amount and then it jumps up, rather than being like a smooth curve.
Yeah, you could think about it like that. That would be like as a function of time, right? Like you're just not investing for some periods, but then you cross some threshold and then you're like, oh, we don't have enough capacity, we better invest. Investment jumps up. Like, yeah, you can do that.
Yeah. Another question about your model, sort of about it. Have you considered putting it into a rather than a sort of like graphical model representation, but into like a sort of like spreadsheet simulation, where you're sort of like showing, in each period, how much the price is either going down or up to match the government price?
That's a really good idea. Yeah, I could work on that. It probably wouldn't be that difficult. I guess if there's interest, I would be willing to do that. Or maybe you could even do it. See if this could be a challenge to you. But I guess I'm sort of waiting for feedback. I'm hoping like people will read this and give me some feedback. I don't feel like the MMTers are really going to be all that interested in this. Because I mean, you saw how much time it took us to go through just a few lines of math, right? And so unless you're already pretty mathy and you do this for fun, then more power to you. But if you're just like a kind of run-of-the-mill MMTer, more interested in like, see, this is one of the things that I've been saying about this model is like, I feel like all the time I've spent on this thing was time like I have not been like learning about the economy, and like doing important stuff. This has a place, it has a value, and that's why I did it. But also like I want to know more about the economy and what's going on, and like, where the bottlenecks are in the supply chains and things like that, and like what specific policy issues we have. And the time spent learning this model is time not spent doing that. So that's like a minor regret for me, or just a cost I had to pay, I guess. And I would not fault anybody who said like, we would rather be doing real stuff with our time rather than playing around with numbers. I wouldn't fault them for that at all. But on the other hand, the numbers are fun. I had fun making this thing. And so if that's what you're into, then yeah, that could be fun.
Yeah, I might be able to do sort of spreadsheet simulation of some version of the model. I mean, I think, because translating the conditions into if-then statements is a lot easier than translating them into calculus. But who might be interested in this is John Harvey, because he's apparently tried to do similar projects in the past where he's tried to put MMT models into mainstream language. And I know he loves the math aspect of it, so maybe he can, give you some feedback on your Euler equations and your Lagrangians. Yeah, I mean, I get what you're saying though about like, every minute you spend sort of explaining something that you already know intuitively is minutes taken away from learning about something new for yourself.
Yeah. It's just like it's not a research project that teaches us very much. What it teaches us is you can tell this story in this language of math. But we already knew the story. It's the same story as the one Mosler tells with the business cards and with the all that.
Yeah, it's the same story, and it's the same story that you told in your other model, your modeling monopoly money model, which I thought was, I read it and I understood it. I don't. It's been a couple years since I read it from start to finish. I don't remember if there was much math that I didn't get, but if there was certainly easier to comprehend than this.
Yeah, right. Isn't that something? Like, this kind of math is just so opaque, right? And once you get down to it, there's not a lot going on in this model, right? And I can explain it with like gallons of milk, and you go like, oh, that's a really simple story. Like, you get gallons of milk from thin air, and you sell some to the government, and like that's kind of about it. But to express that in this language that they use with these techniques is like such a slog, and like, yeah, so opaque. The other version of the model has similar stuff going on, but just without this calculus stuff. It's a lot simpler to understand. And I think that, like, especially this kind of thing, which is supposed to be kind of foundational work, right? Like, science is science, and at a certain point it gets technical, and, it's totally normal that not every person off the street would like understand all the details going on in like some physics paper or something, right? And that's true in economics as well. But like the basic stories should be comprehensible to just like your average smart person who took some high school algebra, right? Like that should be doable, I think. And I do think the other model has some weird things in it for sure, but like not too much that you wouldn't have seen in like pre-calculus. You don't need to do Lagrangians and optimism and all that stuff to work your way through the other model if you're so inclined. So I think that's better in terms of just economics contributing to society.
Do you think there are reverse projects in this nature that could be done, rather than you putting stuff in mainstream models using optimization, rational agents, Lagrangians, and your Euler equations? Could you take a mainstream model and then just put it into simpler language?
Yeah. So the sort of short, quick history here is that this, like, economists used to do that. And then in the 1970s, you get this one paper by a guy named Robert Lucas. This is a famous economics paper where he outlines what is now called the Lucas critique. And the critique basically says that these sort of simpler models have like a fundamental flaw in them, which is that they don't model how people will react to when things change. So like if you take a model, this is one of the examples he gives in the paper. You take a model of like how government spending affects GDP and whatever, and they had those, right? They had big ones too. They had like really, whatever. Anyway. And then you do some kind of policy that's like maybe a temporary tax cut. Okay. Well, somewhere in your model, there is an equation that says like how people react to when taxes change. Okay. And there's parameters in there. So there's some coefficients, some numbers that, determine how big of a response that is. But Lucas says those numbers that you have in those models came from other kinds of situations. They didn't come from a temporary tax cut. People might react to a temporary tax cut differently than they react to a permanent tax cut. And so if the parameters in your model are based on a permanent tax cut, then when you do a temporary tax cut, they might be wrong. The actual response is going to be different than your model says, because your model, the parameters don't capture like how people think. They just capture how people behaved in the past. And so the response from the economics discipline is like, oh shit, this is right. We got to now we got to put optimization in everything, because then the model will respond correctly. If we have optimizing in the model, then we can throw in any policy we want, temporary tax cut, permanent tax cut, whatever, and the agents in the model alter their reactions according to what's happening. And so that's what starts this craze of like everything's got to have optimization in it. That's still ongoing. So I guess the short answer is, to get to what you're saying, we'd have to sort of go back in time. We'd have to rewind the economics profession to before the Lucas critique. Now, one thing that's interesting is that the kinds of models people were making before the Lucas critique, some people are still doing it. They're definitely like more fringy, heterodox people, whereas it used to be the whole discipline did that. But the reason they still keep making them is because it actually mostly still works. Like the Lucas critique is like, hey, your model's going to be wrong. It's not going to capture people's response. They're going to change their behavior. And that's true, and it makes perfect sense. But it turns out that a lot of the time, it's just very small. Like people might change their behavior, but not enough people and not in a big enough a way for it to really make a difference. And so you do your temporary tax cut, and you use your model that was based on a permanent tax cut, and it's like a little wrong, but like not very wrong. It's pretty close. And then on the other hand, these models that do have optimization that respond to the Lucas critique, a lot of the times, because these models are so difficult to build, like you saw all the stuff we had to go through just to get my simple story in there, because these models are so difficult to build, they're often like really, really simple. The situations they describe are like very simple. And so they don't end up being very good predictions of what happens in the economy either. This was one of the big critiques, was that especially after the 2008 crisis, the big models that like central banks were using that have all this optimization stuff in them kept making terrible predictions. The forecasts are like always wrong.
Is it because optimization made it so complicated that they had to have a simpler model for it to, I guess, be valid?
Yeah, basically.
Okay.
Like the kinds of models that you would see before the Lucas critique, they might have a few hundred equations, and it would be like, here's what rich households do, here's what poor households do, here's what the banking sector does, here's what the bond market's up to, here's how the stock market, it just incorporate all these different things and all their interactions and stuff, right? But then the newer versions of the model are like, we have a representative agent, there's just one guy in the economy, right? And he maximizes his utility through time. And, banking sector, a lot of the models didn't have a financial sector at all, right? It's like a guy who decides how much to consume, and like, yeah. So a lot less realism. And then the predictions that came out were garbage.
Has there been anyone who's published like a really well respected and well-cited rebuttal to the Lucas critique?
I wouldn't know like a specific citation off the top of my head for that. Definitely it's been, people have been writing about it for decades. And so I'm sure you could find many rebuttals and responses. So off the top of my head, I couldn't give you a citation, but such things exist.
Okay. Yeah, I was just curious if there was like, one that like most people are, interested in it and have read or whatever, but.
Yeah, not that I can think of.
All right, cool. All right, well, this has been really great. I got some work ahead of me to try to stitch this together into I think it has to be a video podcast, unfortunately, based on the way we went through it. But I think that'll be more useful anyway.
I don't know who's going to watch this thing. Like, I feel like this will be your most boring episode yet.
Well, luckily it's not my podcast, it's Jeff's. So he has to deal with the backlash of, releasing, these episodes over time. People are like, oh, I didn't follow that at all.
Yeah. Well, I'm delighted that you folks have taken an interest in what I'm up to here, and I hope I managed to clarify some of it for you. I will not be offended in the slightest if the broader community is like not interested in this at all, and it's boring stuff. I get that.
No, it's interesting. It's just opaque, like you're saying. Like, most people will get to page 5 and say, oh well, I guess I'll go back to the other paper. But I mean, hopefully at least one person, watches this video as proof of the fact that it's not like, they have those AIs that like spit out, nonsense papers or whatever. Like, hopefully the video will be proof that it's not one of those.
Yeah, I'll take it.
Music for this show is by RecTech. You can find RecTech on SoundCloud and Spotify at WRECK_TECH. To record Activist MMT, I use the iOS phone app Tape-A-Call Plus for recording phone calls and Zencaster for internet-based recordings. My post-production workflow starts by editing on the iOS app AnyTune Pro Plus, then transferring those timestamps to my Windows desktop. At that point, I crudely process the audio in Audacity and then implement the edits and do all the final processing in the Reaper digital audio workstation. Activist MMT is hosted by Libsyn, and the video teasers are created with the online Headliner app.